This is Flip Forte by Engineering Design Group 10.
In this presentation, we will be covering the goals and major requirements of our mini project concept. We will begin by reviewing some use cases and going over the high-level architecture implemented in our design before we move on to demonstrate how our mini project functions through implementation diagrams and a quick video recording. Flip Forte is a program intended to give musicians the freedom to move away from the endless and extensive libraries of paper sheet music and to evolve naturally to digitized sheet music. Currently, it is difficult to make use of the extensive amount of sheet music available for purchase or free download on the internet due to the need to turn the page. This page, intentionally left blank, is used to reduce the amount of times you have to interrupt your playing, as well as physically cutting and taping lines of music when it is impossible to find a good place to turn. Forte was created with the intent to benefit all musicians who work with digital sheet music. By using a hands-off approach, the musicians will not only save time by having to stop and turn pages, but also have the experience of playing without any interruptions. The major requirements that were decided on for the mini project are for the PDF pages to be turned forward or backward when the user presses one of the two analog buttons on the pedal box. A Wi-Fi connection was used to connect the hardware and software components of the project. Lastly, for the display, the application will be viewed on a monitor where the user will also have the option of uploading their own personal PDF sheet music. For the first use case, we have the following scenario. Samantha has been inspired to learn how to play an instrument. She chose the violin and has been practicing with it every day for a few months. She's been getting frustrated with having to stop to turn the pages of her sheet music. When she hears about Flip Forte, she decides to give it a try. After practicing with it one time, she realizes it is everything she needs to learn to play without having to stop and start again frequently. The ease of stepping on the pedals to move forward and back through her sheet music helps her practice more efficiently. Another use case is the following. Mr. Jones has been teaching piano for nearly 50 years and loves it more every day. Sharing the gift of music with his students is clearly his life purpose. He is developing arthritis, and using his hands for long periods of time has become painful and difficult. He would much rather reserve his limited mobility for playing rather than secondary concerns such as turning the page and searching for his students' sheet music. One of his students suggests using a program called Flip Forte so he can eliminate page turning for any student who has a tablet. The student allows Mr. Jones to borrow his device, and it immediately eases his problems. Mr. Jones is still going to struggle with arthritis, but now he can save his strength for what he really cares about. The basic controls of Flip Forte should allow the user to flip pages back and forth. The PDF file is displayed on the desktop by implementing a PDF reader that is powered by pdf.javascript. Electron JavaScript was used to build the Flip Forte app. The three languages that were used to develop it are Node JavaScript, a backend JavaScript runtime environment that executes JavaScript code outside of the web browser, HTML5, a markup language used for structuring and presenting content on the World Wide Web, and CSS, a style sheet language used to change the appearance of a document written in markup languages. In order to connect our Flip Forte app to our pedal box, a command center is used as the middleman for the connection. The command center can be thought of as the communication tool that will act as the middle layer between the software, the application, and the hardware, the pedal box. The command center is developed using AWS on a LAMP, Linux, Apache, MariaDB, PHP server. The pedal box contains all of the hardware that the user interacts with to signal to the command center and subsequently the Flip Forte app that the page should be turned. The pedal box houses analog switches that the user manipulates with their feet. Additionally, the pedal box contains the ESP8266 Wi-Fi enabled microcontroller, which establishes the connection to the command center. The software implementation consists of three main parts: the Command Center API, the desktop app, and the microcontroller. The Command Center API was built on an AWS server which allowed communication over the internet. The desktop application acts as the primary display element and was built with Electron, PDF.js, and Node.js. This is where the user will download and read their sheet music. Finally, there is the Arduino. This is connected to the analog buttons used to turn the pages. The app and the microcontroller are the two items users will interact with. However, they cannot directly communicate due to the limitations of how they work. To achieve this, a custom long pull API using Apache, PHP, and MariaDB on AWS EC2 Linux server was created to allow these elements to communicate indirectly. Here's the hardware diagram of the system. The first challenge in the project was to build an app that could easily serve most major platforms, yet have an appealing yet intuitive user interface. Electron solved these issues by enabling it to be usable on any OS. The second challenge was parsing, reading, and displaying PDF documents in a way that was controllable programmatically. This was achieved using PDF JavaScript library from Mozilla. The communication between the Pedalbox and the desktop app was facilitated through a custom API which stored user input and released it when queried by the desktop app. The main source of technical difficulties was in the software. Originally, the FAU LAMP server was used to host the API. However, it can only deliver data over HTTPS. While HTTPS is secure, the Arduino microcontroller cannot handle going through HTTPS and so much communicate over HTTP. The solution was to use an AWS LAMP EC2 server, which gave the choice between HTTP and HTTPS, so the Arduino microcontroller could continue to be used. And now the project demonstration will begin. Thank you.